Good day everyone, I'm Sir Argelison, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about simplifying radical expressions. Now, in simplifying radical expressions, there are different ways in simplifying radicals. The first one is removing perfect nth powers. So how to do this? We need to break down the radicand into perfect and non-perfect nth powers and apply the property. Okay, so we have here nth root of a, b. That means we need to break that down. So we had nth root of a times nth root of b. For example, we have here a square root of 8, a raised to 9, b raised to 8, and c raised to 13. So we need to break that down so that we can simplify the 8 there. We factor that one into 4 times 2 because 4 is a perfect square. And then 8 raised to 9, we need to factor also this one so that we can divide the exponent to the index here to simplify a raised to 9. So a raised to 8 times a raised times a. And then for b raised to 8, so since 8 can be divided by the index 2, so it can be remained by b raised to 8 na. So we have c raised to 13, so factor that one, so we have c raised to 12 times c. So since we can now simplify this one, so square root of 4, that is 2, square root of a raised to 8, so 8 divide 2, so we have a raised to 4. And then b raised to 8 divide to the index, square root of b raised to 8, we have b raised to 4. And then c raised to 12, we can, square root of c raised to 12, we can simplify this one. 12 divide by the index, so we have c raised to 6. Now, the remaining values in the radical, we have the square root of 2, a, and c. Since they cannot be simplified, so they will be remaining in the radical radical sign. So we have the answer here: 2 a raised to 4, b raised to 4, c raised to 6, square root of 2ac. The next one, we have reducing index in the lowest possible order. Express the radical into an expression with a rational exponent, then simplify the exponent or apply the property. We have here the m root of nth root of a, so equals to m times nth root of a. That is also equal to nth root of m root of a. So we can break down also the, if we have here, for example, note the 20 index. So since some of the terms here cannot be simplified by the 20 index class, so we have 20 root of 32 x raised to 20 and y raised to 25. So we can break down the index here into 4th root of 5th root, since 4 times 5 we have 20 man. So then simplify here the radicand here. So we have here 5th root, so we have 2 raised to 5, that is 32, and then x raised to 20 and y raised to 25. Now we need to simplify this one. The 5th root of 2/5, that is 2, since 5 divide 5 is 1, 2 raised to 1. 5th root of x raised to 20, so copy x, and then 20 divide 5, we have 4. So we have x raised to 4, and y, 5th root of y raised to 25, copy y, 25 divide 5, we have 5. So now the answer is 4th root of 2x raised to 4, y raised to 5. Or, here, since we can simplify pa in 4th root of 2x raised to 4, y raised to 5, no, we can simplify x raised to 4 and y raised to 4 times y. We need to factor this one. So the 4th root of x raised to 4, 4 divide 4, we have x. And then 4th root of y raised to 4, we have y. So the remaining values in the radical or in the radicand, we have 4th root of 2 and y. So the final answer is xy, fourth root of 2y. Or we can express this one into rational exponent. So we have here, for example, we need to express this one. So 32, that is 2 raised to 5. And then x raised to 20, y raised to 25. Or you can put 32 here. And then again, in how to change radical to exponent into rational exponent. So we just need to the exponent here in the radicand, that is the numerator, which is 1. And then the index is your denominator. So that means we have 2 raised to 5, x raised to 20, y raised to 25, raised to 1 over 20. So next step, we just need to distribute the 1 over 20 in each variable. So we have 5 times 1 over 20, we have 2 raised to 5 over 20. Then we have 20 times 1 over 20, we have x raised to 20 over 20. And then we have 25 times 1 over 20, we have y raised to 25 over 20. Simplify the exponent, so we have 2 raised to 1 to 1/4, x raised to 4 over 4, and y raised to 5/4. Now, we can change this one into radical form na to simplify the given radical. So, since we have the same denominator na as 4, we can raise this 1. So we have 2x raised to 4, y raised to 5, raised to 4. And then change this one, the exponential form, into radical form. So your exponent will be your so the exponent here will be your, so here in the radicand, okay, so the base here is your radicand now, and then your exponent, you raised to 1 is your exponent, and your exponent here is your denominator. So we have here fourth root of 2x raised to 4, y raised to 5. And then we can simplify pa, no, the fourth root of x raised to 4 is x, and fourth root of y raised to 4 is y. So the remaining values here is xy, fourth root of 2y. So we have the same answer. So it's up to you, what will you use, no, the reducing into index in lowest possible order, or into change it into rational exponent. Okay, let's simplify each radicals. So we have here number 1, square root of x raised to 9. So all we need to do is we need to factor x raised to 9, which is the one, the first variable is a perfect, the first term is a perfect square, and the second term is a non-perfect square. So we have here square root of x raised to 8 times x. So since 8 can be divided by the index 2, so we can simplify this one as x, square root of x raised to 8 times square root of x. So square root of x raised to 8, you just need to copy the base, x, and then divide the exponent to the index. 8 divided 2, we have x raised to 4. And then the remaining value in the radical sign, we have square root of x. So x raised to 4, square root of x. Number 2, we have cube root of y raised to 8, z raised to 10. So we just need to factor each terms or in the radicand, so that the terms, the first term will be simplified or can be divided by the index, and the second term is a non-perfect square. So we have here cube root of y raised to 6 times y raised to 2. So we factored y raised to 8, diba? So y raised to 6 times y raised to 2 is equal to y raised to 8. Since y raised to 6 is a perfect cube and y raised to 2 is a non-perfect cube. And then we need to factor z raised to 10. We have z raised to 9 times z, because z raised to 9 times z is z raised to 10. Okay? So simplify this one. We have cube root of y raised to 6 times z raised to 9 times cube root of y raised to 2 and z. So all you need to do here is you just need to separate the terms that can be simplified and the terms can be remained that is a non-perfect cube terms. So we have here the cube root of y raised to 6. So we have copy the base and then divide the exponent by the index. 6 divide 3, we have y raised to 2, and z raised to 9, copy z, and then 9 divide 3, we have 3. And then you just need to copy cube root of y raised to 2 z. So the final answer is y raised to 2, z raised to 3, cube root of y raised to 2 z. Example number 3, we have square root of 75 d cubed. So we just need to factor 75, which is the first term will be perfect square and the other term is a non-perfect perfect square. So we have here 25 times 3, that is 75, since 25 is a perfect square. And then d raised to 3 also, you need to factor that one, d raised to 2 times d, that is d raised to 3. So separate the terms that can be simplified and the terms that cannot be simplified. So we have square root of 25d squared, so that is square root of 5 is at 25 is 5, and square root of d squared is d. And then the remaining terms in the radical, we have square root of 3d. So we have the final answer, 5d square root of 3d. Example number 4, we have square root of 100 a raised to 5 b cubed. So just simplify this one. Since 100 can be simplified, square root of 100, we have square root of 100 times a raised to 4. Factor a raised to 5, we have a raised to 4 times a. And then factor b cubed, we have b squared times b. So we have here square root of 100 a raised to 4 times b squared times square root of a and b. So we have square root of 100 is 10, square root of a raised to 4 is a squared, square root of b squared is b, and then just copy the remaining radical sign there, the radical. So we have 10 a squared b square root of a b. Number 5, we have square root of 45 x cubed y 8 squared. Y raised to 8, sorry. So factor 45, we have 9 times 5. Since 9 is a perfect square, and factor x raised to 3, we have x squared times x, and then factor y raised to 8, we have y raised to 8 there, since y raised to 8 is a perfect square. So we have here, we have square root of 9 x squared y raised to 8 times x raised times square root of 5x. And then simplify, square root of 9 is 3, square root of x squared is x, square root of y raised to 8 is y raised to 4. And then copy square root of 5x. So your final answer is 3x y raised to 4 square root of 5x. Okay, example number 6, we have cube root of 64, a raised to 5 and b raised to 14. So we have here square root of cube root of 64. Since 64 is a perfect cube, so we don't need to factor that one, times factor a raised to 5. So we have a raised to 3 times a raised to 2. Factor b raised to 14, we have b raised to 12 times b raised to 2. And then we have cube root of 64 a raised to 3 b raised to 12 times cube root of a raised to 2 b raised to 2. What is cube root of 64? We have 4. Cube root of a cube, we have a. Cube root of b raised to 12, we have b raised to 4. And then copy cube root of a squared, b squared. So our final answer is 4ab raised to 4 cube root of a squared, b squared. Next, we have cube root of 135 m raised to 10 b raised to 12. So we have here factored 135, we have cube root of 27 times 5, since 27 is a perfect cube. Factor m raised to 10, we have m raised to 9 times m, and then we have times b raised to 12. So we have cube root of 27 m raised to 9 b raised to 12 times cube root of 5 and m. What is cube root of 27? Is 3. Cube root of m raised to 9, m raised to 3. Cube root of b raised to 12, we have b raised to 4. And then cube root, copy cube root of 5m. Number 8, we have fourth root of negative 14, a raised to 3, and b raised to 11. Now, let's have a recall about the radicals, no rule of radicals class. If you have a radicand that is a negative value and your index is an even number, that means the solution, that means there is no real root. Again, if your radicand is a negative value and your index is an even number, even, that is 2, 4, 6, 8, 10, 12, and so on, that means diretso class, no real root ang answer. Number 9, again, analyze the terms. If you have a negative radicand, you check your index is an even number, that means there is no real root for that. Example number 10, okay, you check your radicand that is negative but your index is an odd number. In the rule for that, if your radicand is a negative real number and your index is an odd number, that means there is a unique solution or one solution for that. That means we can simplify this one. So we have here, we need to factor negative 40. We have negative 8 times 5, since negative 8 is a perfect cube, and then x raised to 9, and then factor y raised to 10. We have y raised to 9 times y. So we have here cube root of negative 8 x raised to 9 y raised to 9 times cube root of 5y. So we have here cube root of negative 8, we have negative 2. Cube root of x raised to 9, we have x raised to 3. Cube root of y raised to 3, we have y raised to 9, we have y raised to 3. And then copy cube root of 5y. So our final answer here is negative 2 x raised to 3, y raised to 3, and cube root of 5y. Number 11, we have here cube root of 2 raised to 5, 5 raised to 6. So again, you just need to factor that one so that you can simplify the terms in the radicand. We have cube root of 2 raised to 3 times 2 raised to 2 and 5 raised to 6. So we have here, since cube root of 2 raised to 3 is 2, since 3, divide the index 3 and the exponent 3, 3 divided 3 is 1, so we have 2 raised to 1, times the cube root of 5 raised to 6, we have 5 raised to 2, and the remaining value in the radicand is cube root of 2 raised to 4. Now simplify. We have 2 times 25 cube root of 4. So 2 times 25, we have 50 cube root of 4. Next, we have 5c raised to 4, d raised to 2, square root of 9 over 25, c raised to 20, and d raised to 30. Now, you check the terms in the radical. We can simplify the terms there. So you just need to copy 5c raised to 4, d raised to 2. What is the square root of 9? 3. Square root of 25? 5. Square root of c raised to 20? C raised to 10. Since 20 divide 2 is 10. Square root of d raised to 30? D raised to 15. Since 30 divide 2 is 15. Now here, you can simplify this one. You multiply the terms without variable, and then you multiply also the variable with exponent here. So we have here 5 times 3 over 5. Now the loss of exponent, when you multiply the same variable or the same base, you just need to add the exponent. We have c raised to 4 plus 10, d raised to 2 plus 15. So 5 times 3, 15, 1 times 5, we have 5. So we have 15 over 5, c raised to 14, d raised to 17. Simplify, 15 divide 3, we have 3, c raised to 14, and d raised to 17. So that is our final answer. Last two examples. We have example number 13. We have 15 square root of a raised to 10, b raised to 5. So since we can't simplify we can't divide the index to the exponent of the radicand, so we need to use the katong rule B. No, we need to reduce the index. So we need to cube root, change that one into cube root of fifth root of a raised to 10 b raised to 5. No? Since if our index is 5, we can simplify this one here. So we have here cube root of b raised cube root of fifth root of a raised to 2 raised to 5. Now we need to factor this one to simplify and be b raised to 5. So what is the fifth root of a raised to 2 raised to 5? So we can cancel 5, divide 5. The remaining value here is a raised to 2, and fifth root of b raised to 5, that is b. So your answer is cube root of a raised to 2b. Or you can change that one into rational exponent. So we just need to change. So a raised to 10, b raised to 5, b raised to 1 over 15, since our exponent here is 1. No, if you don't see any exponent here, you can use 1 there, class. So it's already understandable that your exponent is 1. And on your index, your denominator is 15. So distribute the exponent there to the variables, the exponent of the variables. We have a raised to 10 times 1 over 15, b raised to 5 times 1 over 15. So we have 10 times 1/5 over 15. So we have a raised to 10 over 15, and then b raised to 5 times over 15. We have 5 over 15. So simplify, we have a raised to 2/3, b raised to 1/3. Now we can change this one into radical form, class. So since our denominator now is the same, so we can change that one into a squared b raised to 1 raised to 3, or you can change that one into radical form now. Your exponent will be your index, so we have 3 square root of a raised to 2b. Next, last example, we have 12 root of 81 c raised to 4 d raised to 8. So we can reduce the index here. We have cube root of fourth root of 81 c raised to 4 d raised to 8. And then we have here now, we need to factor the radicands here. Cube root of fourth root of 3 raised to 4, c raised to 4, d raised to 2 raised to 4. Simplify the fourth root here. So we have here cube root of 3 c d squared. Or you can change this one into rational exponent. We have c raised to 4, c raised to 4, d raised to 8, raised to 1 over 12. And then you distribute the exponent to the exponent of the variables here. So we have 3 raised to 4 times 1 over 12, c raised to 4 times 1 over 12, d raised to 8 times 1 over 12. So simplify, we have 3 raised to 4 over 12, c raised to 4 over 12, d raised to 8 over 12. Now, simplify. So we have 3 raised to 1/3, c raised to 1/3, d raised to 2/3. And then you change that one into radical form. We have cube root of 3cd squared. Again, thank you so much for watching, guys. I hope that you've learned something out of this video. Please don't forget to like and subscribe. And if you have questions, you can comment down. Thank you and God bless everyone. Goodbye.